All right, well, this is going to be the other half of lesson 2.4, where we're dividing rational numbers. So that'll look like dividing fractions and dividing mixed numbers and whole numbers, dividing decimals. But some of them can be positive, some can be negative. Sometimes they're both negative, sometimes they're both positive. So let's take a look here. We're really combining a lot of different things that we know now, a lot of different rules. And if we keep them all straight, these actually are pretty easy problems. Number 10. Well, we've got negative 7 over 10 divided by 2 over 5. Now, if you'll recall, we don't divide fractions. We actually invert the second fraction and multiply. I think some of the sixth grade teachers say same, change, flip, which what they mean is they keep this one the same, they change this to multiplication, and you flip this fraction here. If that helps you remember what we're doing, well, then so be it. So we'll keep this first fraction, negative 7 over 10. We turn it into multiplication, and we use the reciprocal of 2/5, which will be 5 over 2. An important part to remember, and we've used this already this year, when we're supposed to divide by 2/5, we can actually just multiply by 5 over 2, and we get the same result. So dividing by a number and multiplying by its reciprocal are the same thing, or get the same result. Now we can simplify before we multiply. I know 5 goes into 10 twice, and 5 goes into 5 once. 7 times 1 is 7. 2 times 2 is 4. So I get 7 over 4. I look back at the original problem, and I have a positive and a negative, one of each. So my answer is negative. Different signs, negative, when we're multiplying and dividing. And here we're multiplying. Actually, we started by dividing. We turned it into multiplying, but the same rule. Different signs, negative, when we're multiplying or dividing. I'll turn this back into a mixed number. 4 goes into 7 one time with 3 left over. So negative 1 3/4. Number 11, much the same. We have 1/4 divided by negative 3/8. And it doesn't matter where we put that negative. We can have it up front, on top, on bottom, or out front. It doesn't matter. We'll just put it up top right now. But we are going to keep this first fraction, turn it into multiplication, and invert this second fraction, 8 over 3. And now that negative would be down here, which is no big deal, but I just like to have them up top, so I'll move it back up top here. 4 goes into 4 one time. 4 goes into 8 twice. 1 times 2 is 2. 1 times 3 is 3. Different signs, so it's negative. Negative 2/3 for number 11. For number 12, we have negative 8 over 9 divided by negative 8 over 9. Well, I have something divided by itself. Anytime we divide something by itself, we get 1 as an answer, with the exception of 0, of course, because you can't divide by 0. But regardless, this is something divided by itself. We're going to get 1 for an answer. But let's pretend we didn't know that rule. We'll just keep the first fraction, turn it into multiplication, invert the second fraction. 9 goes into 9 once, 9 goes into 9 once. 8 goes into 8 once, 8 goes into 8 once. 1 times 1 is 1 over 1 times 1 is 1. Same sign, so it's going to be positive. Positive 1 over 1, which is just 1. Like we already said. Number 13. Negative 1 over 5 divided by 20. Now, we have to turn them both into fractions here, so negative 1 over 5 divided by 20 over 1. And now I'll keep the first fraction, turn it into multiplication, invert the second fraction, multiply across the top. 1 times 1 is 1. 5 times 20 is 100. Different signs. So my answer is negative 1/100th. Negative 1/100th. Number 14. Negative 2 4/5 divided by negative 7. So same sign. My answer is going to be positive. I know that ahead of time. Turning these both into fractions. 14 over 5 divided by negative 7 over 1. Keep the first fraction. So negative 14 over 5, turn it into multiplication, invert the second fraction, negative 1 over 7. 7 goes into 7 once, 7 goes into 14 twice. 2 times 1 is 2, 5 times 1 is 5. And same sign, so my answer is positive 2/5 for number 14. For number 15, still fractions. One more fraction. It looks like we get into decimals here. We have negative 10 2/7 divided by negative 4 4/11. Both negative, so I know my answer is going to be positive here. Turning them both into fractions, I get 72. 7 times 10 is 70, plus 2 is 72 over 7 divided by 11 plus 4, 11 times 4 is 44, plus 4 is 48 over 11. Now, boy, I wish I could simplify right now. Actually, no simplification could be done right now. Now I get to invert. So keep the first one, 72 over 7. Turn it into multiplication. Invert the second fraction to have its reciprocal here of negative 11 over 48. Now, 72 and 48 are both even, but I know actually 4 can go into both of them. In fact, 8 can go into both of them because I know 9 times 8 is 72. So 8 goes into 72 9 times. 6 times 8 is 48, so 8 can go into 48 6 times. And yikes, I could still simplify by 3. 3 goes into 6 twice. 3 goes into 9 3 times. In fact, 72 and 48, I could have divided both of them by 24 had I known right off the bat. Well, now I've got 3 times 11 for the top, 33. 7 times 2 for the bottom, 14. And on number 15, they were both negative. So my answer is positive 33 over 14. 14 goes into 33 2 times with 5 left over. So 2 and 5/14 for number 15. Number 16. All right, we're into decimals, which some of you might think is a little easier, but with fractions, I think multiplying and dividing fractions is the easier. But for number 16, this is negative 9 divided by 7.2. What we're dividing by is what goes out in front of the box here. So 7.2, negative 9 in the middle here. Well, I don't divide with a decimal out here. I move that decimal one spot. That's really just multiplying this by 10 to move it one spot. But I have to multiply this by 10 as well, which really is just moving this decimal one spot. Even though you can't see the decimal, we're moving it one spot. Have to put a 0 in there to hold that place. So this problem becomes 72 into negative 90. Well, 72 goes into 90 one time, which is 72, of course. 90 minus 72 is 18. Could have showed your borrowing there. Put a decimal. Annex a 0. Make sure that decimal goes up into our quotient as well. Bring that 0 down. 72 goes into 180 twice, which is 144. Subtract to get 36. Bring down a 0. And 72 goes into 365 times. 5 times 72 is 360. So I'm all done. 1.25 or 1 and 25 hundredths. But if we look back at number 16, different signs. So our answer is going to be negative 1.25. Number 17 is 8 divided by 2.2. Both positive, so my answer is going to be positive. But for number 17, make sure the 8 divided by 2.2, the 2.2 is what's going out on the outside, and the 8 goes on the inside. I need to move this decimal one spot, so I move this decimal one spot, filling in with a 0, of course, making this 22 into 80. 22 goes into 80 3 times, which is 66. Subtract. Bring down a 0, but don't forget to put that decimal up in your quotient. 22 goes into 146 times. 12, 13, so 132. Subtract 8. Bring down a 0. 22 into 80 is going to go 3 times. Wait a minute, I already did 80 up here. This is just going to keep repeating because I get 66 again, and so on and so forth. So I'm going to put that repeating bar. The 6, 3 is going to keep repeating. I could not put the repeating bar over here over the 3, 6 because that decimal's in the way. Our repeating bars always go after the decimal only. So the 6, 3 keeps repeating. 3.63 with the 6, 3 repeating is what we get for number 17. For number 18, remember this first number goes in the box because it's negative 3.45 divided by negative 15. The negative 15 is what goes on the outside. So negative 15 dividing into negative 3.45. Wow, I didn't leave much room for my quotient up there. I don't have to move the decimal anywhere because I don't have a decimal showing out here. So that decimal goes straight up into our quotient there. 15 goes into 34 twice. 2 times 15 is 30. Subtract. Bring down. 15 goes into 45 3 times. Let me cheat a little more paper up there. That's better. 15 goes into 34 twice, we said. Oh, that's much better, which was 30. 15 goes into 45 3 times, which is 45. So 0.23 or 23 hundredths for number 18. And remember, both of them are negative, and when we're dividing, that means our answer is positive. Number 19. Negative 0.18 divided by 0.03. Well, the 0.03 is going out front here into negative 0.18. I need to move this decimal 2 places to hide it back there. So I have to move this one 2 places, which makes this problem 3 on the outside and negative 18 on the inside. Well, 3 goes into 18 6 times, which is 18. Well, that was a nice, easy problem. One of each, a different sign, so my answer is negative. Negative 6 is the answer for number 19. 2 more problems. Number 20. This second number goes outside, so I've got the negative 3.56 there into my 8.722. I move this decimal 2 places, so I move this decimal 2 places, which now makes this negative 356 into 872.2. And that decimal goes straight up into my quotient. Well, 356 goes into 872 twice, and that would be 10, 11, 6, 7, 7, 12. subtract 0, 6, 1, bring down the 2. And 356 goes into 1602, let's say 5 times. 5 times will probably be too many. Let's go 4 times. 4 times would be 1,424, just by doubling when I multiplied it by 2. Subtract, and I get 178. Okay, so which that is less. So I was right. Bring down a 0, and it'll go into 1780, I believe, 5 times. 5 times 356, that'd be a 0, an 8, 15, 16, 17. Yep. So number 20, we get 2.45, or 2 and 45 hundredths. But remember, different signs to start this thing out, which makes it negative after we're done dividing. Negative 2 and 45 hundredths. Last problem. Number 21. And on number 21, we have 12.42. 12.42 divided by negative 4 and 8 tenths. Move the decimal once, so I move the decimal once, which makes this negative 48 out here and 124.2 in there. Putting that decimal straight up into my quotient right away so I don't forget. 48 goes into 124 twice, which is 96. If I subtract, I get 28. Bring down the 2. 48 goes into 282 5 times. 5 times 48, 40, 24. Subtract 42. Bring down a 0. 48 goes into 428 times. 8 times 48 would be 64. 32 plus the 6 is 38. Subtract and get 36. Bring down another 0. 48 goes into 367 times. 7 times 48 would be 350 minus 14, so 336. Subtract 240, and 48 goes into 240. Look right there. When I multiplied by 5, it was exactly 240. Wow, thank goodness, because I don't want to keep this thing going. 5 times 48 is 240. So we're all done here. 2.5875, or 2 and 5,875 10,000ths. And remember, we started off this problem with 1 positive and 1 negative. So our answer is negative. Excellent. Well, now go over and go back to journal page 40, which you looked at yesterday when we were multiplying rational numbers. But today you look at it, and today you're just looking at problems. So today you're going back to J40, journal page 40, and you're looking at 4, 5, 6, 8, 9. Those are the problems you're looking at on journal page 40. The video for that is up. Thank you.